At 3:44 in the morning, a truck backs up to a hatchery loading dock in northwestern Arkansas. The driver has been on the road since 2 a.m. The cargo is live. Specifically, it is 102 trays of day-old chicks, approximately 7,650 birds, each one hatched within the past 18 hours, each one already eating and vocalizing in the climate-controlled compartments stacked in the truck's interior. The temperature inside those compartments sits at 86 degrees Fahrenheit. It will stay there for the duration of the drive, however long that drive turns out to be. Because the chicks cannot yet regulate their own body temperature, and cold exposure in the first hours of life produces mortality rates that the system cannot absorb. The truck will make 6 stops this morning. Each stop is a contract grower's farm. At each farm, the chicks will be unloaded, counted, and placed into a grow-out house that the grower prepared 10 to 14 days ago. Cleaned, disinfected, out preheated, and bedded with fresh litter. By the time the driver completes the last stop and turns back toward the hatchery, more than 45,000 Pilgrim's Pride chicks will have started the 42 to 49-day cycle that converts a day-old bird weighing 1.8 ounces into a market broiler weighing 6 to 9 pounds. Pilgrim's Pride operates one of the largest vertically integrated poultry production systems in the United States. The company coordinates over 5,600 contract growers raising broiler chickens across multiple southern states. It owns the breeder flocks, the hatcheries, the feed mills, and the processing plants. It produces over 5 billion pounds of chicken annually. And the mechanism that moves all of it, from fertile egg to retail package, is a pipeline built on the contract integration model that the American poultry industry invented and refined over 70 years into the system running before sunrise in Arkansas this morning. The broiler chicken that Pilgrim's Pride produces is a different animal from the chicken that existed before the mid-20th century. Before selective breeding for commercial meat production began in earnest after World War II, the chicken consumed in the United States was primarily a byproduct of egg production, old hens whose laying productivity had declined, or young cockerels culled from egg-breed flocks. These birds grew slowly, reached modest weights after months on range or in small farm flocks, and were available seasonally. Chicken was not a cheap protein. It was a luxury, consumed at Sunday dinners and special occasions. The development of the commercial broiler breed, a bird selected for rapid growth, efficient feed conversion, and a body conformation that emphasized the breast muscle that American consumers preferred, changed that relationship between chicken and cost over 2 decades of concentrated genetic selection. By the 1960s, broiler breeds were growing to market weight in 8 to 9 weeks. By the 1980s, 7 weeks. By the 2000s, modern commercial broilers were reaching market weight in 42 to 49 days on feed conversion ratios of approximately 1.8 to 2.0 pounds of feed per pound of gain. The genetics that produced this trajectory sit at the top of the Pilgrim's Pride system. The company maintains pedigree flocks, pure genetic lines with specific growth, conformation, and disease resistance characteristics, at secured facilities. These flocks produce the great-grandparent generation. Great-grandparents produce grandparents. Grandparents produce the parent breeder flocks that lay the fertile eggs that move to hatcheries. The commercial chick placed on a contract grower's farm is 4 generations removed from the foundation genetics, and the performance it delivers, the growth rate, the feed conversion, the breast yield, reflects the accumulated genetic selection pressure applied at every generation above it. The genetic supply chain is proprietary. Two companies, Aviagen and Cobb Vantress, supply the major genetic lines used across the commercial broiler industry in the United States. Pilgrim's Pride, like the other large integrators, licenses these genetics and manages them through the multiplication pyramid that produces the commercial chicks its contract growers raise. The performance standards built into those genetics determine every downstream economic parameter: how much feed the bird consumes, how quickly it reaches target weight, what percentage of its live weight is breast meat. The hatchery is the industrial node that converts fertile eggs into day-old chicks at the volume the contract grower network requires. A Pilgrim's Pride hatchery operation produces chicks in quantities measured not by the 1,000, but by the million, weekly. The company's 13 billion chicks annually divide to roughly 250 million per week across its hatchery network. Each hatchery serves a defined geographic region because the logistics of moving day-old chicks impose strict time limits. A chick can survive 48 to 72 hours without feed or water, sustained by the residual yolk absorbed just before hatching. Beyond that window, without access to feed and water at appropriate temperature, mortality rises sharply. Fertile eggs arrive at the hatchery from Pilgrim's Pride-owned breeder farms. They are transported in climate-controlled vehicles that maintain eggs at 65 to 68 degrees Fahrenheit, the temperature that holds embryo development suspended during transit without chilling the egg to temperatures that impair hatchability. The eggs move into setter incubators within hours of arrival, where they spend 18 days at 99.5 degrees Fahrenheit and 55 to 60% relative humidity, turned automatically every hour to prevent the developing embryo from adhering to the shell membrane. At day 18, the eggs transfer from setters to hatchers, incubators configured for the final 3 days of development at slightly lower temperature and higher humidity, where the chick completes its development, absorbs the remaining yolk, and pips through the shell. Hatch day. Day 21 of incubation produces a hatchery floor covered in wet chicks, vocalizing loudly, still downy, pulling free of shells. The post-hatch processing line moves the chicks through a sequence of automated steps within hours of hatch. Sexing in some cases, vaccination by spray or eye drop, beak treatment if specified by the production program, and quality sorting that removes chicks below the weight or mobility standard that the grower placement protocol requires. The entire process moves at the throughput speed the hatchery capacity supports. Hundreds of thousands of chicks per day at large facilities. The chick boxes that load onto the delivery trucks hold 100 chicks each in a vented corrugated container. The truck driver this morning carried 76.5 boxes. By the end of next week, that hatcheries will have loaded thousands more deliveries. The contract grower receives the chicks, but the relationship between grower and integrator extends well before placement day and runs deep into the economics of both parties. A contract broiler grower typically owns 2 to 8 growing houses. They'd each built to Pilgrim's Pride's specifications for dimensions, ventilation, feeding and watering equipment, and litter management. A standard modern broiler house runs 40 to 60 feet wide and 500 to 600 feet long, roughly 25,000 square feet of floor space, and holds between 25,000 and 35,000 birds per flock, depending on the target market weight. The construction cost for a new house in the range of $300,000 to $500,000, meaning a 4-house grower operation represents $1.2 million to $2 million in facility investment before the first chick arrives. Pilgrim's Pride provides the chicks, the feed, the veterinary services, the medication program, the technical support from a company service technician, and the guaranteed market for the finished birds. The grower provides the land, the facilities, the utilities, the litter, and the labor, primarily the grower's own labor and family labor in most cases, with hired workers during the intensive periods of flock management. The payment structure is a tournament system. Growers receive a base payment per pound of chicken produced, and then that payment adjusts based on their flock performance relative to other growers in the same settlement group. Typically the group of growers whose flocks processed in the same week at the same plant. Growers whose flocks convert, feed efficiently, grow to target weight quickly, and show low mortality receive a premium over the base. Growers whose flocks underperform relative to the group receive a discount. The same chick genetics, the same feed formula, and the same company protocols apply across all growers in a settlement group, but individual grower skill in managing house environment, litter quality, and bird behavior generates performance differences that the tournament system translates into payment differences. The tournament structure is designed to incentivize grower performance without the integrator paying premium prices for all production, regardless of quality. It is also the most contested element of the contract relationship. Growers who perform below the group median receive less than the base rate for reasons that may include factors outside their control, including the genetic quality of a specific hatch, the health status of chicks at placement, or the feed formulation that Pilgrim's Pride controls, and the grower does not. Inside the grow-out house, the environmental control system runs the biological conditions that determine flock performance as precisely as any other element of the production chain. Day-old chicks require temperatures of 86 to 90 degrees Fahrenheit at bird level, not air temperature, but the temperature where the chick lives, close to the litter surface. Propane, or natural gas brooder heaters, maintain that temperature during the first week, while the birds develop thermoregulation capacity. As the flock ages and the bird's own body heat contributes to house temperature, the heating requirement declines, and ventilation becomes the primary environmental management tool. Modern broiler houses use tunnel ventilation, large fans at one end of the house pulling air through the length of the building when at full operation, with inlet pads at the opposite end providing evaporative cooling during summer conditions. The control system manages fan staging automatically based on temperature sensors positioned at multiple points through the house, adjusting airflow to maintain the target temperature range across the full floor space. Ammonia management is the other critical environmental parameter. Ammonia gas, produced by bacterial decomposition of uric acid in the litter, is corrosive to respiratory tissue at concentrations above 25 parts per million. Chronic exposure at even moderate levels reduces bird respiratory health, impairs feed intake, and increases susceptibility to bacterial infections that reduce performance and increase mortality. The ventilation system that manages temperature also controls ammonia by removing the moist, ammonia-laden air that accumulates near the litter surface and replacing it with fresh air from outside. Lighting programs, the duration and intensity of light in the house, influence broiler feed, intake, activity, and growth rate. Extended dark periods allow birds to rest, which reduces leg injuries and metabolic disorders associated with the rapid growth rates of commercial broilers. The control system manages lighting schedules automatically, running programs that balance feed intake promotion with the rest periods that reduce welfare and performance problems. The automated feeding and watering systems that run the length of each house deliver feed and water continuously. Feed moves through a chain or auger system from bulk bins outside the house through feed pans distributed at regular intervals across the house floor. Water moves through nipple drinker lines at heights adjusted upward as the birds grow, encouraging birds to drink without creating the floor wetting from spillage that degrades litter quality. Feed is the variable that defines the economics of broiler production more than any other, and Pilgrim's Pride's 24 feed mills operate the supply chain that maintains feed delivery to 5,600 contract farms without interruption. A flock of 30,000 broilers growing to 6.5 pounds live weight in 47 days consumes approximately 165,000 pounds of feed during the grow-out period, roughly 5.5 pounds per bird. At 5,600 growers with average farm sizes of 4 houses each at 30,000 birds per house, the total bird population on feed at any moment approaches 670 million birds. At 5.5 pounds of feed per bird over a 47-day cycle, the daily feed demand across the full system exceeds 78 million pounds, 39,000 tons per day. The 24 feed mills that supply this demand source, corn and soybean meal, the 2 primary ingredients in broiler rations, from regional commodity markets, purchasing ahead to lock in supply at acceptable prices and storing in grain bins adjacent to the mill. Lalia broiler starter ration for day-old to 14-day-old chicks contains higher protein, typically 21 to 23% crude protein, to support the rapid early muscle development. The grower ration from day 15 through approximately day 35 reduces protein slightly as the bird's lean growth requirements shift relative to its larger body mass. The finisher and withdrawal rations in the final weeks reduce protein further and adjust medication and feed additive profiles based on the withdrawal periods required before processing. Feed trucks leave the mill on delivery schedules calculated to keep the bins at each house full without overfilling to the point that feed sits in hot bins long enough to develop mold or rancidity. In summer heat, across the southern states where Pilgrim's Pride operates, feed quality can degrade in bin storage within days if moisture and temperature combine unfavorably. The delivery scheduling system accounts for that risk, calibrating delivery frequency against expected intake rates for the flock age and season. The service technician assigned to a group of contract growers monitors feed bin levels as part of weekly farm visits, alerting the mill when a farm's consumption is running faster or slower than projected, a deviation that can signal either environmental management problems affecting intake or health challenges that reduce the flock's appetite. The service technician role sits at the interface between Pilgrim's Pride's centralized protocols and the daily reality of 5,600 individual farm operations managed by 5,600 different growers. Each technician carries a territory of 25 to 40 farms. The weekly visits cover house environment, litter condition, bird behavior, feed and water consumption, mortality rate, and any health challenges developing in the flock. The technician does not own the birds, does not control the feed formula, and does not manage the processing schedule. What the technician does is translate the company's production protocols into practical guidance for each specific grower, identify problems before they compound, to coordinate veterinary response when health challenges require it, and serve as the primary communication channel between the grower and the integrator's field operations team. Flock health monitoring has incorporated real-time electronic data collection that supplements the weekly technician visit. environmental controllers in modern houses log temperature, humidity, and ventilation data continuously. Feed and water consumption, tracked through bin-level sensors and meter-based water readers, generates daily data on intake patterns. Mortality is counted by the grower daily and reported to the technician's management system, where it accumulates into a flock mortality curve that the veterinary team compares against expected patterns for the bird age and time of year. A flock mortality curve that rises sharply in the first week, above 0.5% mortality in the first 7 days, triggers veterinary investigation. Because early mortality at that rate often indicates a hatch quality problem, a respiratory disease challenge introduced at placement, or an environmental condition in the house that compromised the birds before they established. Mortality that spikes in week 3 or 4, after the flock appeared healthy through the early period, follows a different diagnostic logic. Typically infectious bronchitis, Marek's disease expression in flocks with incomplete vaccination coverage, or clostridial infection associated with litter quality deterioration that allowed necrotic enteritis to establish in the intestinal tract. The veterinary team's response to mortality events works through the technician, identifying the likely cause from the mortality pattern and flock history, adjusting the health program, in some cases collecting birds for necropsy at the company's diagnostic laboratory, and making medication or management recommendations that the grower implements in the house. The live haul, the transport of finished broilers from contract farms to the processing plant, completes the grow-out cycle and begins the harvest chain. Pilgrim's Pride coordinates transportation fleets that move finished birds from farms across each complex's geographic territory to the plant on a schedule calculated to maintain plant throughput at target levels. The plant's kill floor capacity, the number of birds it can process per hour, determines how many flocks must arrive per day, which determines how many farms must reach harvest weight per day, which drives the placement schedule that put chicks on farms 6 to 7 weeks earlier. The live haul operation typically runs at night and early morning. Catching, removing birds from the house requires darkness, because broilers in the dark are calmer and easier to handle than broilers in full light. Catching crews move through the house, picking birds from the litter floor and placing them into transport modules, plastic crates stacked on a flatbed or in a containerized truck body, at a pace that minimizes handling stress. Catching is physically demanding work. A 7-pound broiler multiplied by thousands of birds per house, handled in the close quarters of a floor-to-ceiling packed grow-out house, generates significant physical strain and heat, especially in summer conditions where the house environment stays warm even at night. Industry data consistently documents catching crew injuries, hand and wrist strain from the gripping motion, respiratory exposure to dust and ammonia, heat stress, at rates higher than the general agricultural workforce. The transport module design attempts to balance bird density against ventilation during transport. Birds packed too tightly overheat. Birds with too much space shift during transit and create crushing risks. Module stocking density specifications balance those competing risks against the vehicle's load capacity and the expected drive time to the plant. Bird mortality in transit, dead on arrival at the plant, represents a direct financial loss that the live haul system tries to minimize through careful stocking, ventilation management in the transport vehicle, and route timing that keeps total transit time short. The plants that regularly receive high DOA rates investigate the catching and transport chain for the specific farms or routes generating the problem. The processing plant receives live birds, and within a few hours converts them to retail and food service products shipped in refrigerated trucks across distribution networks covering hundreds of miles. Pilgrim's Pride's processing plants handle throughput measured in hundreds of thousands of birds per day. A large plant running 2 shifts at 140 birds per minute processes more than 100,000 birds in an 8-hour shift. The kill floor, the evisceration line, the chilling system, and the cut-up and deboning operations run as a continuous flow that cannot pause without accumulating live birds that have not yet been processed and finished product that has not yet reached refrigeration. The production schedule that determines which farms supply which plant on which day drives the entire upstream system. When a plant schedules 100,000 birds for processing on a Tuesday, it needs farms with 100,000 birds at market weight, ready for that Tuesday. The placement schedule, which farms receive chicks, at what density, targeting what market weight, flows backward from that processing date. Pilgrim's Pride's production planning team manages this schedule across the full system. You're adjusting for farm performance variation, mortality rates, and market demand shifts that change the target weights and volumes the plant needs. The chicken that Pilgrim's Pride processes moves into multiple product forms: whole birds, fresh bone-in pieces, boneless, skinless breast and thigh, wings, value-added marinated products, and fully cooked items. The mix of product forms reflects the demand signals from retail buyers, food service customers, and the export markets that take product specifications that domestic markets don't absorb. A breast-heavy market pulls trim production toward debone and reduces whole bird output. An export order for dark meat trims product that domestic retail doesn't value highly and converts it into a revenue stream that markets in Mexico, Russia, or Asia absorb. 5 billion pounds of chicken per year. The figure divides across 52 weeks into roughly 96 million pounds per week. Go divided further across the plants, the flocks, the hatcheries, and the 5,600 contract farms that supply it all. At any moment in the Pilgrim's Pride system, some of those farms have day-old chicks on fresh litter, just placed this morning from the hatchery trucks. Some have flocks at 3 weeks, halfway through the grow-out, past the early health challenges, growing fast on grower rations. Some have birds at day 45, approaching harvest weight, waiting for the live haul crew. The pipeline runs continuously because the chick placement schedule never stops. Farms that empty after harvest clean out and prepare for the next placement. The clean-out window, removing old litter, disinfecting the house, applying new bedding, heating the house back to placement temperature, runs 10 to 14 days. Then the hatchery truck arrives again. The contract integration model that Pilgrim's Pride operates represents the complete industrialization of what was once a small farm activity. The genetics are centralized. The feed is centralized. The health protocols are centralized. The market is guaranteed. The only thing distributed across 5,600 locations is the floor space, the electricity, the water, and the labor, and the financial risk of the facility investment that the grower carries. The system built around that structure produces chicken at a cost and scale that no other organizational model has matched. It made chicken the most consumed meat protein in the United States. And it runs before dawn on the back of a truck making 6 stops across the rural South. If this look at the integrated system behind 5 billion pounds of chicken annually gave you a clearer picture of how the modern food supply actually works, Hit the like button and help the algorithm find more viewers who want this level of detail. Subscribe for more deep dives into the production systems that run quietly behind everyday products. Drop a comment and tell us where you're watching from. We read everyone, and the reach of these videos continues to surprise us.